caveat that up front. My name is Paul Dolly. I'm a technology strategist with Microsoft. For my sins, based in New Zealand. Co-presenting with you today, we have Victor Kochikov. Victor's been called many things, most of them good. Today he's a voice architect, right? So that's what we're heading in. And we're going to talk to you today about link interoperability with other non-Microsoft platforms. So predominantly focusing on voice and video, because those are the two key topic areas which we've got. Now we think about interoperability with other platforms, then you can also think about what instant messaging, what about presence exchange and those types of things, all right? Now fundamentally there's an edge server session which is tomorrow morning, okay, and they're going to talk more there around what we call public internet connectivity for federation, around IMMP and how that comes in. So this session we're really focusing around the core communications of voice and video and how all that comes together and how we interoperate. So first half of the session I'm going to cover off and look at video rooms and how they play, be it telepresence, be it room-based systems, how to get it into the desktop and all those types of things. And then we're going to look at PABX interoperability. So if you just come out of Brendan and Salvin's session, all right, so they touched on, moving to voice, talking about moving to voice or going big with voice, using Link as a PBX. We're going to touch a little more detail around, I have a PBX today, how do I interoperate that? How do I make that play nicely with Link? And how, there are different ways. So we're going to investigate each of those different methods and then drill into what is, really the Microsoft preferred or suggested method for integration with other PABX platforms. And Victor's going to drill into more detail around on there. So capping that all off, we'll look at migration approaches as well, because the end game for most customers is, if they're looking at doing Link for voice, for video, is to use it as a complete replacement platform, But there is that phase or that time, which could be an extended period, where you would have a legacy PBX in for a number of different reasons, not always technical ones that come in. So that's the a summary of the agenda. So just to set the scene up front in terms of when we look at Link and interoperability, really there's a number of ways in which we really try and drive that. One of the biggest challenges in the industry today is trying to get vendors together and making all their platforms play nicely, all right? There's not many greenfield scenarios where you can go out, as Microsoft or as customers where you have a new clean slate to start from scratch, More often than not, there is a lot of legacy video platforms out there, there's legacy voice platforms out there, and really we need to get it to work, And the best quote I saw around this was, there are a lot of UC vendors out there providing lots of parts of UC, but really there's no one vendor that provides everything end-to-end, right? Now, I'd like to think as Microsoft we get pretty much down the way, but absolutely there's key components that we need to interoperate and bring in to offer that full solution that you may need for your business. So we call it interoperability by design, and I suppose there's really three ways, right? Brendan touched around, and you saw his Nigeria bank demo, right? So he used some of the APIs, right, using UCMA, and how he pulled in there to interoperate and then pull through applications. But then there's a couple of other ways in which we really look at platforms and voice and video and how they come into play. So we actually have a program called OIP, or the Open Interoperability Program. And that was really designed back in the days of OCS 2007 as to how we can get legacy PBXs with voice systems to play nicely, so we could communicate between Link and between those platforms. So we set out a specific list of criteria where any vendor could come in, they could bring their PBX, they could bring their gateway, they could bring their PSDN trunks, their SIP trunks in, and we could actually go and test that against Link. Independent testers, so this is not done by Microsoft, these external parties. They basically run through the checkbox. Does it meet all the criteria in terms of testing? And they're very significant tests in terms of to get there. We'll then publish that vendor, that particular revision of software or hardware or PBX, whatever it is, onto our OIP site and saying, yep, ticks the box, right, we can interoperate. And it's not just about ticking that box and doing all of that stuff. It's also about how do you provide documentation to actually go out there and deploy and support this stuff going forward, right? So it's more than just a technical validation, of all of these things. So it has to be supportable as well. The other method, and this is relatively new, is something called the UCIF, or the UC Interoperability Forum, right? Which is a whole group of vendors coming together, if you will, all right? Everyone like-minded in trying to drive interoperability, okay? Because there are standards and there are standards, right? And standards are interpreted differently across many vendors, which is why we have the challenges we've had today with interoperability around on here. So us, along with HP, Polycom, a couple of others, were the founding members of this. And it's open as an organization, right? So any vendor can come out there and join this, and we're there. There's sort of regular meetings, they all talk. You know, let's look at this codec. Well, how about this as a standard? We can all work and move to this. You will notice a couple of absent friends from there. You know, I'm not going to call them out, but someone said Cisco. And I didn't see a Avaya on the list either, but hey, all right. But, you know, it's an open forum. Anyone could come and do this. And it really is driving significant change in how we do interoperability and how we drive some of this stuff. So we really see this as key, you know, moving forward. And the number of vendors is growing, you know, rapidly. I'm not sure when we pulled those logos off from there. So there may well be more on there now, you know, for sure, as it comes through. So fundamentally, that's really going to drive this stuff, you know, once we get all that playing nicely together. Okay, so that's enough of the overview. So what about video rooms and video rooms interoperability? How do we make those play, you know, with link server? So again, the high level of the strategy is really around 3 spheres, all right, or 3 areas what we're really trying to drive. And this has been the vision back since, if anyone was doing the days of LCS 2005, which was great, and I had hair, and it was all wonderful back in the day of doing this stuff. Right? You know, we had this vision about video anywhere, ubiquitous, just like voice, you know, driving high-def video right across the desktop, you know. That became a reality, and is a reality today, you know. We've seen HD-type webcams for PCs, etc., at price points that have just tumbled around where you would never think of doing HD before. Absolutely, you know, there are bandwidth overheads and considerations. You've got to do that. And again, the session after that looks at some of the detail around network considerations to do things like high-quality video on there, but you can drive it to every desktop. Okay? Absolutely do that today. Also tied in with that, though, is really around the experience and the end-user experience. So if you're familiar with OCS 2007, when you wanted to do a conference, say video conference, call it that, right? You had a different client and a different experience as a user, all right? So the usability became a challenge for some people, and, you know, and that part of OCS wasn't potentially as widely used as it could have been. Now that changed with Link Server 2010 in the fact that we have that single user interface that does all of my communication needs now. You know, it's a single client approach. But again, that really needs to apply when we look at interoperability, all right? If I bring in a room endpoint, I don't really want to try and make the experience different for users, because that's when we have challenges, you know? That's when it starts to become this silo platform again, and it's just a room somewhere that somebody goes and books and does video, but it's just the board, or, you know, they play with those things. No one else can do or access the telepresence system and get in there. So taking that meeting room experience and really taking it from the point of where it leaves the desktop as being the viable option, you know, up through the small meeting room. You may have seen, you know, the roundtable type devices, the Polycom 5000 device that does that for that small meeting room, and up through other endpoints now, all right? So again, talking on Polycom, they had a 7000, which is in the showcase in there, which they've got, they just launched, which is a native Link HD endpoint. The very, very clean user interface that looks just like the Link client. So any user can walk into that meeting room and use that, being familiar with Link, you know, as an endpoint. So there's lots and lots of these native sort of endpoints. So the meeting room experience is really starting to change. But then interoperability, you know, how do we take those legacy systems and bring those in? Because those are big ticket items for any organization, right? You know, you invest in a room-based platform, you know, you've got to sweat that asset down over a number of years. It's got to stay and it's got to be there. We need to hook the thing in and bring that through. So bringing that in via gateways and third-party hardware is really how we do that, okay? And we'll talk through the detail. You know, we're talking Link as a SIP-based platform and how we're bringing in these other endpoints, maybe H323 or other legacy protocols that they're using today, and tie them into the mix. So that's the strategy. Now, with the interoperability program, up until about 6-8 weeks ago, it would have been, we had no real interoperability program around video. All right, so it was based around voice, it was based around devices, SIP trunks, gateways, IP PBXs, and all these types of things. We never had this sort of clear interoperability program around video. So now we have that, and we've launched that, and it allows any vendor of video systems, you know, VTC platforms, to come in and test and interoperate, and we can tick the boxes and do all of that criteria to make sure it works nicely with Link. So that's with OCS 2007 R2 and Link Server 2010, right? So we're not forgetting that there's still a lot of that stuff that's out there in the marketplace today. Now, there's a slightly different requirement between the two. It's listed on the chart at the bottom there. With Link 2010, we really talk about how we can take RTV, as a codec in HD, all right, and allow multi-party conferences using Link as the MCU, right? So Link is the conference holder and organizer and distributor of those calls. Typically with VTC systems, they would have their own MCU, hardware-based MCU, that would offer that as a platform, all right? So there's a sort of shift here in how we can take that through the Interop program, and we can have a single point of control. And again, a lot of that is about driving a seamless experience for users in terms of how I book a meeting, how I access that resource, how I go in and schedule it and bring it into a meeting. So making it very, very sort of easy and intuitive as we go through. The key three tenets, if you like, of the technical scope around this stuff. Okay, so it's really around three paths, right? Registration, access and security, and around seamless interop in terms of taking all of the endpoints coming in. So from a registration point of view, right, so we're looking at how we do this MTLM, TLS space, all right? So we have secure registration all the way through from these endpoints. We can tick the box and we can get that through. The middle one is really talking about, if you're familiar with Link today, how the anywhere access philosophy transfers out and can now play with video, right? So using things like ICE and firewall traversal, so I can be sat internal or external to the network as a device, and I can connect in and become part of that same conference, okay? So we're not mutually saying that has to be part of the corporate environment in terms of that end device through. So it's no different from a Link client that we have today, be it an IP phone or be it the soft client, and how we map that out there. And really the third end is around these high quality sort of endpoints that are starting to embed the Link codecs. So RTV in there to drive video natively to that endpoint so we can have direct registration and direct peer-to-peer type communications between a desktop Link client and a video endpoint coming through there as well. CCCP or CCCP, that's sort of another area where when you look at ad hoc conferencing today, if you've got myself and Victor on a video call, if I want to drag somebody in, I can just drag and drop them into that video conference, right? Effectively, we got a three-person call. Now, doing that with the same capability, but bringing in the video room as that third or additional endpoint into that mix. Okay, so that's some of the testing we do around there to pull that in as well. So primarily, you can see the names of the partners who are listed there are really leading and driving this charge. Not saying there won't be others who ever come to there, but we have committed partners really driving around direct registration and endpoints, and around the sort of the gateway MCU approach, so we can do sort of pass through and integration with the legacy stuff as it comes in there. I suppose I'll caveat the question up front. People will say, well, what about Tandberg and where does that fit into the mix on here, right? Because prior to Cisco's acquisition of Tandberg, they had a roadmap around taking a codecs and doing some of this stuff, right? There is nothing committed or happening in terms of that space in there, okay? So really, in terms of going through the OIP, the Interop program, partners who we work and test with, you can see the ones who are listed down there, or go on the site and see those. The other question that comes up, and customers that have Cisco telepresence deployed today, all right? So again, very, very big ticket item in terms of deploying those rooms. But if I'm now pushing Link out to the enterprise, how can I ensure that that room is just a silo and it sits there and it just gathers dust when I've got users now who are more mobile and want to do conferencing from the desktop and video from the desktop and bring that in. So with Cisco telepresence, they use a protocol called TIP, all right? So it's a Cisco proprietary protocol. I love to say Cisco proprietary because someone needs to try and throw the other side of the fence to come through there. But it's a Cisco proprietary protocol that they use, and how do we get that in the mix? Really, the recommendation in terms of approach to actually get TIP into working with Link endpoints as it comes through there, you have to go through a hardware gateway, such as a Polycom RMX or Ravvision gateway, to actually bring that in there so we can bridge that together. But it's not excluded, right? So the fact of whatever the size room, whatever the situation in terms of the deployment or the legacy platform that's out there, all the way through to sort of the telepresence environments, we can make that all part of the same ecosystem and move in. Step back. So the gateway approach. So again, with point-to-point calls, there's several ways of really doing this, and different vendors have implemented this in different ways as it comes in. So in this scenario, we have our Link user and our Link server, And we're showing logically a media gateway and a signaling server, right? Typically, that would be a single physical box you've actually got in there, but just to break out and show the sort of flow of traffic as it comes in. So everything on the link side of the house, okay? So we're looking at SIP and TLS, and we've got our RTV video stream, which goes into our media gateway as it comes in. Very simple media gateway, if you're familiar with Link and OCS, think mediation server in what it's doing, converting our RTA audio codec to G711 and pumping that out the other side. Here what we're doing is then using that gateway in very much the same way for video and pushing that out, and whether it needs to be 264, 323, or whatever it is, the format that sits on the other side of the fence as it comes through there. All the registration, call presence, etc., in terms of endpoint presence exchange, comes through and affects through the signaling server. Comes in. The only thing that's missing there, and fundamentally what's always been done around legacy, is there is no hardware-based MCU in the mix on here, okay? So Link AV MCU is providing that bridging capability between them all, okay? So that's something that's a little bit different. So in this case, we have an endpoint from a legacy platform just coming through effectively a media gateway to convert and transfer through into Link. Where there is a hardware-based MCU in the mix, and that could be because you've already got legacy video platforms that are out there, whatever they happen to be, you know, as it comes in there. So we have our video endpoints. We now still potentially have multiple streams coming through into that media gateway. In terms of the Link side of the fence, nothing changes through there with this type of scenario, right? So that's the sort of virtual room approach, where you could be using the hardware MCU as that bridge, or again, using the Link AV MCU to actually pop that through. Now, when we look at, you know, I've just drawn up an example of a Polycom and a Tandberg communication between a Link client and a video endpoint, all right? So, you know, in this scenario, we have on the left-hand side, we have a Link client, and you can see the media stream between a Polycom HDX unit is going direct peer-to-peer, okay? There is no gateway in the mix to transcode there. Now, that's because, you know, HDX on the Polycom side have embedded, and they have RTV sitting on there, right? We don't need to do any of that transcoding, and we can take that HDX and we can have a straight, you know, peer-to-peer call and use all the advantages that we have with RTV and the elastic codec and things moving up and down around there. And obviously all of our signaling traffic happening and popping in through the Link server as it goes through there. Again, the comparison really here around Tandberg. Let's put them up as probably the two most widely deployed sort of platforms that are out there in the marketplace, you know, today. To do that sort of HD quality video between those endpoints as it goes through there, you really need a couple of boxes on their side, which is their VCS and their AMG, their Advanced Media Gateway. There's some scale issues as it hits on there, is with an AMG popped in, which again is a pretty, you know, expensive bit of kit. What you have is only 5 sessions of HD video going through there, and you're capped off. All right, you can daisy chain and build those things up as it goes through there, but you've got to have pretty deep pockets to sort of get to that approach, you know, and move through there. But again, regardless of the endpoints, it can be done. All right, someone's saying 10, not 5. All right, I was understating. It's only 50% around there. But regardless of the endpoint, you can get it through. It just depends at what point of hardware we actually need to go through. So with that, what I'll do, I'll just drop out and just show what that looks like. Now, I know if you went to Andrew's session yesterday, you may have seen some of that stuff. Just wait for my PC to flick over on the screen. Should probably give a prize to who can recognize where the stadium is. Silence. God, there's no Portsmouth supporters in the house. So it's all good.
Sorry, what support?
Yeah, okay. So, anyway, right. So, Link client. I would drop down, and I've got some demo endpoints on here of HDX units that we have scattered around various networks and geographies, depending on which time zone we use is what we can call. We'll click on this one here. We see a Polycom APAC. This is actually based up in Singapore. All right, so I can start a video call directly as if I'm doing a peer-to-peer desktop call straight to a user. All right, no different from there. All right, so that'll start up. That'll auto answer that end, and the video will start the HDX, and there it goes. And it's dropping that in sort of SIF quality in the window video as it goes through. Now, because we're negotiating and we've actually dropped that call using RTA as the codec, right? It's peer-to-peer. There's no hardware in between there. The media stream's going direct. what will actually happen is if I pop that video out of there, you'll see the advantages of RTV is how it then upscales, right? If we've got the available bandwidth to do that stuff, all right? So we can go all the way up through sort of 720p beyond VGA, then up to 720 type style. And as I double click it, you'll see that step in a couple of seconds, assuming we've got the bandwidth on the wireless networks. That's all I'm using right now. There we go, in at VGA, then again a couple of seconds later, if we get there, bang, that'll pop out at 720p, right? So that's a Polycom HDX camera just stuck looking out of their window in the street in Singapore as it goes in, right? So, you can sort of, you don't really appreciate the quality so much on these projectors in terms of getting that quality through on there. But, you can do that natively. Very, very powerful if you want to have a desk to room-based video solution. You can see even on wireless, we sort of get the, the flow in terms of what's happening around there. You can see the traffic moving along the street. So that's a peer-to-peer call. So effectively, we're not using any MCU to actually do this stuff. Okay, there's no AV MCU either on the Polycom side of the fence or on the Link side of the fence. Okay, in that mix. So the other demonstration really around video, which I'll bring up, is if you dial in and use an MCU from the video guys, okay, you can then start to do other things such as continuous presence. So continuous presence or Brady Bunch, as it's called, right? So, one of the things people say about Link is how do I get multiple video streams into that window so I can see all 4 people or all 10 people into that single video mix, right? So that's not done natively out of Link, all right? So, we have active party switching. So whoever talks, it will switch and you will see their video as it comes through. Yes, you can add in a panorama from a roundtable device on top of that, but that's the limitation in terms of the quantity. So now if I actually connect in and use the Polycom side of the fence as an AV MCU, well, I can have people connecting in and we can actually get into that bridge and we can create that effect when we see that there. So let me just find that one. So here we go. I'll just right click and start another video call. This will look a little bit different to a traditional Link call when it comes in. So let's start up. Okay, so we see we're hitting the Polycom RMX bridge, and if I bring that out of screen a bit, there'll be a different number around there. We get some meeting information as it comes through, and you see we also get video information of, we got, 4 people now sat in here. Let me bring that up and go full screen around there. And we can see the names of the users who are coming out in that screen, okay? And you can see, bang, we now got another one comes in the mix. We've got a Sydney room in there, again, down in Sydney that's come in there. So we've now got, 1, 2, 3, 4, 5, or whatever, video parties coming in, all done on the same screen, all right? So you can see now how we're bridging that together. And Mike sat in the front there just holding the thing up in terms of his PC. So there's a few of us connecting in on wireless. And I believe your bridge, you were saying, is over in the US. Yep. All right, so in terms of what we're doing with traversing media, to actually do this stuff, you can see, where the media path's actually going from and to actually bring this up, okay? And again, if I just pop that out even to my small Link window, you'll see I still get that same view in terms of the video with a multi-party there, right? So, some customers, it's very, very compelling and they really require, they're used to that type of continuous presence or multi-person view around there. Absolutely, we can still deliver that, through Link and other platforms on the mix as well. Okay. Flip back over. That's it on video. I mean, it's pretty quick, right? It's pretty straightforward, to be honest, right? How much detail you can get through there. It's either direct registration with a peer-to-peer type call. Again, depending on the vendor, is whether you need a gateway in there in the mix or you go direct, as we showed on the demonstration there. And you can have hardware-based AV MCUs coming into the mix, where you can then, am I using Link as that AV MCU? Am I using the video rooms-based AV MCU as that choice? But there's careful consideration in design and how you really get through and do that stuff. But really, I suppose the point or the takeaway to get it through there is you don't have to go away and throw away that room-based system if you want to make that interoperate. Regardless of potentially what it is or what vendor it is or what revisions it happens to be, there are ways to get that moved in the mix and get it working together. So that takes us through video, and second up we're going to look through about voice and IP-PBX interoperability. So this is far more common in terms of a scenario that comes up all the time. be it a long-term type interoperability approach, or be it how you look at migrating from a legacy PBX to a link platform for voice. Now, really, there are two approaches you can take in how you would take a legacy PBX platform and integrate or interoperate with Link, okay? Now, that's client-side or server-side. Pretty straightforward. But then once you look in the server-side types of integration, there are multiple methods of server-side integration and how we bring that in. So we pumped all four up on there today, and I'm just going to give a few sort of pros and cons around each of those, and then get Victor to delve into what we call direct SIG integration, which is probably the most common that we're seeing out there in the marketplace today, and some of the configuration and considerations that need to be taken in there around that one. So client-side integration, what is it? All right, so we're exposing APIs from the Link client, okay? And from those, a number of PBX manufacturers have gone out and effectively built headless clients within Link, all right? So it sort of dumbs down Link to being an instant message and present engine, but use all of the call control and everything else stays with the legacy PBX platform, okay? On the surface, right, I know a lot of customers have sort of looked at that and it's seemed really, really appealing because it sounds pretty simple because it's just a bit of client software I need to deploy and I'm integrated and I'm away, all right, as it goes through there. The reality around this stuff, and the best thing I say to customers is they really say, well, I can really do this at a low cost, I want to give it a go, is go pilot it and try this thing out, all right? Because regardless of whichever the vendor or whichever the PBX is around there, the experience from a user point of view or the user standpoint gets horrible, all right? It is not great. Things get broken. Some of the capability I had around Link, around drag and drop or click to video or like click to conference, that just goes, right? You lose all of that capability out of the mix as it goes on there. So we typically, always say, pilot Link, pilot client-side integration, pilot one of the other methods, and really see how that works for your user community. That's probably, the best thing I can really say against that stuff. You may need additional licenses, right? So there's a cost perspective that comes into this mix here as well. So it may not be as free as it looks, on the surface as it comes through. And whilst it sounds simple, it's just a client-side integration. Look at the caveats that might be listed around, okay, what does the OS version need to be? Does it support 64-bit Office? How does that now work when I want to try and pull in SharePoint and do click-to-call or whatever it is I'm doing around other apps and bringing into the mix, okay? That can suddenly make a very, very simple integration on the surface become a lot more complex, okay? Harder support, higher TCO, and all those other types of issues that really come there. But again, probably the biggest issue we've seen with this and concern that we've had feedback from is a disjointed user experience. Now, absolutely, we provide those APIs from the client, right? But it's not stuff that we've developed and promoted as software in terms of how to interoperate, with a PBX. This has been done, by a number of other vendors for their particular platforms, and how they push it through. But it's one way in which you can really take a PBX and you can interoperate it, Second method we're going to look at, and this was touched on in Brendan's session, and again, we're going to cover it at the end here when we look at migration. And this is really probably the best way you would go and do a proof of concept, all right? So you have a PBX today. How do I then evolve and put a pocket of users or pilot users community on to Link and do voice, all right? So there are a couple of places we can do this. So if you have a really old PBX that doesn't support IP or it doesn't support SIP, we can't do a direct connection between that and Link, okay? There are a number of our sort of certified gateway providers that are out there, all right? Effectively taking the SIP that comes out of Link through the gateway and supports any number of protocols right into that PBX, I saw a customer with a sort of 30-plus-year-old PBX with only had analog connectivity out of the thing, and they hooked it up through a gateway to get the thing working, right? But pretty limited functionality. You could make some calls, but that was about it, right? But it allowed them to move pockets of users off so they could shunt calls between the two platforms, and they could pilot enterprise voice using Link as it goes through. So it's a way in which you can really do that and test it, without impacting much configuration work on the PBX or how it goes through. Now, how you position that gateway or where you position that gateway would really depend as well. Because if I have a full-time plan to move production to Link going forward, then do I put it between the PBX there? Or do I put it, what we call upstream, above the PBX, sort of, if you can imagine the E1 lines or the PSTN lines coming in to the legacy PBX, breaking that in and putting the gateway above the PBX, which then connects to Link. So the gateway has some intelligence and pre-routing, if you like, to send that call to the appropriate location. Okay, so that's another way, very, very useful around migration, and I think we've got a bit of detail around that in the end as it comes in. So it is the most basic form of interop. Okay, so very, very useful if you want to do a proof of concept or a pilot, and prove the value of Link, and prove the capability of Link. You know, it allows direct calling between there. Is it a long-term solution? Well, some would say, yeah, it can be as it goes through there. But what are we really protecting in terms of that legacy investment? Is it something we really want to keep anyway as it goes through? But you know, it can be there, and it can allow you to perhaps sweat the support out of the old PBX platform as it comes in, or even potentially keep that as the PSTN gateway and just use it to bring my lines and trunks through into Link as we move forward. So there are a lot of different scenarios where that really plays and as it comes in. But most benefit, if you want to use a really old PBX and get that stuff and try some Link out, hey, if you don't do SIP trunks directly with a separate standalone platform, then yep, this will absolutely take you there and allow you to do that. The other, or one of the other server-side types of integration we have is RCC, or remote call control. All right. So now, effectively, what we have is we have the PBX platform, we have the Link platform, and we actually use, which is pretty much a legacy PBX protocol called CSDA. All right. So we use SIP over CSDA from Link to allow us, effectively, from my desktop to control my PBX phone. Okay. So all of my media, all of my voice calling stays with the PBX, but allows me to take presence and IM from my desktop client. And when I click to communicate, it can pop my PBX phone hands-free, if it's a hands-free capability, and initiate that call on my behalf and use the PBX. Okay. Some types of users, that could be the ideal scenario, right? So Brendan touched on, when he was talking about voice with Link, is, or Selvan, profiling of the user community. You know, what do they really need? You know, if you have a user that is only based 100% at his desk, traditionally uses a phone and, you know, for calling or high volume calling, then remote call control may be an option to consider for that user. It may be a way of actually doing that stuff if you're going to be keeping that PBX over a longer period of time. You know, if the user is very, very mobile, then, hey, you know, is that really the right approach? Because all of my call control has been dumbed down out to my PBX phone from Link. So a lot of the flexibility and capability we have in Link as a platform gets degraded or negated through this approach. So in summary, in terms of what you get around here, yep, you get inbound and outbound calling and all that usual stuff as it goes through. You know, I could forward my desk phone in terms of call forwarding from the client as it goes around there, so controlling that sort of basic functionality. And I can call via my desk phone or call outbound via Link as it goes through there. Stuff that breaks, though, what's missing if I go to that? You know, I have click to call, effectively, is what I'm saying, right? Is what you really get out of this. What you really miss around this is, how do I escalate to multi-party? How do I drag and drop around there when my media stream is now still staying out on the PBX? All right, it's gone. With Link today as well, we don't support video with remote call control, okay? Splitting out the media streams and having video control going through Link with voice control going out through the PBX, right? The architecture that changed between OCS and Link made that very, very hard to actually keep in and replicate. You know, we're working at how we can get potentially video back into RCC for peer-to-peer calls from clients, but you know, you're not going to get that split media, if you like, between the two. So I can't just click to call Victor, use my PBX phone, and then escalate to video and get through that stuff, right? So that's something that's not going to work, fundamentally broken around when you do this stuff. And again, because we're effectively just using the Link client as a controlling path for the PBX phone, I mentioned this already, right? What about the flexibility? What about the remote access? What about the remote working? How I can then leverage that for all of my calling as it goes in. Synchronizing of other features or PBX features, like if I go do not disturb on my client, does it always map in? Will it go DND on my phone as well, which is the native experience, obviously, with Link as we get through. So those types of considerations and features which really get knocked off the back as it goes there. Inbound calls, right? An inbound call, I've answered it on my PBX phone, control's gone there. How do I escalate and get that to a sharing session? Again, you're having media going through multiple paths around there, okay? So some of the stuff that's actually lost. There's a few other things on there, but just highlighted a few of the key features that are in there and what aren't in there. But again, depending on your user profiling, hey, it may work for that person that just sits at a desk all day, 9 to 5, and makes and receives calls. Right? They have that click-to-call capability with what they got. And these methods of integration, they're not mutually exclusive. It's not a case of, right, well, I'm going to go down the remote call control path, so that excludes me from doing something different for another set of users or a different community within my user base as it goes in. So all of that can be pulled in the mix. The final one, and we're going to get through this in a little bit more detail in terms of technical depth around here, is what we call direct SIP integration. So here is where we're taking an IP PBX that has SIP capability and ideally tested through our OIP, our Open Interop program. So again, if you look up on TechNet for OIP, you'll see a list of all the PBXs that have gone through, have been tested there to actually do direct SIP. And again, with any caveats or config notes that need to be taken into account to actually get that playing. So now, just in that video scenario, what we have here is a link client communicating with the PBX, okay, and the servers are going direct with no hardware in the mix to actually between the two. So with that, I'll actually pass over to Victor. Take us through.
Yeah, thank you, Paul. So before going with link and direct SIP integration, let's briefly review what we have with OCSR2 in case of direct SIP integration. First of all, we have a very good number of certified IP gateways and IP PBXs, which you can find on Open Interoperability program site. And you can definitely establish a direct SIP connection with these PBXs and IP gateways. However, with OCSR2, we have some limitations, or I would say some challenges, because OCSR2 will require a media flow through the mediation server every time you have a call going to that IP PBX or gateway. Moreover, in OCSR2, there is one-to-one mapping for mediation server to a single gateway. So should you have 10 gateways, you have to install 10 mediation servers. It's not a big issue for single-site deployment or for central-site design. But if you have a lot of branches, now your media have to flow through the WAN link to the central site where your mediation server is installed, or you need to install a mediation server in every site. You can see on the diagram. So the red one is a signaling which can go through the front-end server, the mediation server, and finally to IP PBX or voice gateway. The media has to flow through the mediation server every time. Moreover, in this case, the unnecessary transcoding will occur because OCS endpoint will talk RT audio to mediation server. Mediation server will transcode it to G711, and any type of transcoding will affect voice quality. So it's a good point to avoid any unnecessary transcoding. With link, it's completely different because we're introducing a media bypass. And I will talk in details about media bypass. But the key component of it, it's actually giving you an option to do a direct media flow between link endpoint and IP PBX or voice gateway. In this case, link endpoint will use G711 codec to talk to a next hop. However, the signaling will still flow through the front-end server and mediation server, which in link case can be just a service running on front-end server, so less boxes required. Moreover, the single mediation server instance now can talk to a number of gateways. Finally, you can have just a centralized pool of mediation servers in your main location, and then all your branches can be talked to a IP PBX or IP gateway through your central location for signaling, but then using media bypass to keep media locally. So first of all, media bypass removes the need to transit the media through the mediation server every time. However, as I mentioned previously, the signaling can still flow through the mediation server, and there are a couple of reasons. First of all, it's the security and demarcation point, as well as it's useful for any future additional options for interoperability. And with media bypass, now media goes directly to the next hop. It optimizes quality, it removes that unnecessary transcoding. And also G711 itself has less CPU load on an endpoint. So it's actually increased the performance of endpoint as well. But media bypass in some cases might not be required. For example, you need to make a call over the WAN link. You definitely do not want to use G711 for that call. So, but media bypass itself is quite intelligent option, and it can occur only on a local network. So you can configure link server to use your call admission control settings to identify where the user is located and switch on media bypass only when the next hop is local to the user. However, for WAN calls, you can still use media to flow through the mediation server. In this case, the link endpoint will talk RT audio to the mediation server, and the mediation server will transcode it to G711, as it has been done in OCSR2. The media bypass actually allows us to use a mediation server as a service because there is no transcoding, so less CPU overhead, so we can run it as a service on the front end. There are two ways you can enable media bypass. First of all, you can globally enable it to media bypass always. I would not recommend it to any deployment, but however, you can still use it for a single site deployment. Another way is to use a media bypass in conjunction to your call admission control configuration. In this case, a link server, mediation server, or link endpoint will make a decision about using media bypass based on the media bypass ID, which are also based on the network information. So there are two logics in how link determines that media bypass. First of all, for inbound call, the mediation server, when it receives the invite from the remote gateway, it will then check the IP address within the SDP information, because it might be different from the signaling IP address, right? So it will check that IP address of the destination media. Then we'll check the network site and regions configuration within the call admission control settings to determine the media bypass ID. Then it will send it in the SDP information to the link client. When link client receives that information, it will compare. And by the way, mediation server can fork it and send it to different destinations because you can be logged into a number of link endpoints. So it will be forked, sent to every endpoint, and endpoint itself will compare the media bypass ID of its own and one which is included into SDP, and make a decision, should I bypass or not? And by the way, when you're bypassing the media, the call admission control will not be aware about it. So it will not take into consideration any call admission control settings. So this is why you don't want to use media bypass on WAN links. On the other hand, on the outgoing call, the link client will include its own media bypass into SDP and set it to mediation server. Now mediation server can determine the next hop gateway media IP address, compare it to the media bypass ID of the link endpoint and make a decision about should I bypass or should I actually transcode it. So on the Open Interoperability Program website, there is a list of all certified and tested voice gateways and IP PBXs. Be careful and check all the details because media bypass doesn't work with every listed IP PBXs and voice gateways. There is some limitations with a number of IP PBXs, for example. In some cases, media bypass can work for outbound calls only. It doesn't work for inbound calls. With other PBXs, it can work both directions or cannot work at all. So we will check how to configure media bypass on that example using Cisco Call Manager. Just to give you a highlight of the design. So it's a single site configuration. We have a call manager, we have an MTP, which might be a software-based MTP running on the same box as a call manager, or it might be ISR or hardware router with hardware MTP. Doesn't matter. It will work in both approaches. We have a link front-end server with a mediation server running as a service on it. In this case, the signaling will flow as a yellow route on the diagram. So it will flow through the front-end server mediation and hit the call manager. However, the media will go directly between link and MTP resources on the Cisco side. To enable this, you will need to do a couple of steps within your topology builder, as well as within your link control panel. Alternatively, you can use PowerShell script to define all the settings and then apply that PowerShell script. Don't forget to check everything within the control panel after you applied script. So let me, at this stage, actually jump to demo. So I'm not going to show you a PowerShell script. You can easily download examples of PowerShell scripts from Microsoft site. But what I'm going to do, I will show you the key components of the media bypass configuration. First of all, in network configuration, there is a global settings where you can enable media bypass globally or disable it. Be aware that when you're enabling call admission control, so you will not be able to enable always bypass. So the one or another. So, but definitely call admission control is a good feature. I would recommend you to enable every time. Yeah.
I'm just wondering why you would do media bypass, why you wouldn't just pump the media stream through the link server as well?
A number of reasons.
Just repeat the question.
Pardon?
Repeat the question for.
Yeah. The question is why we're actually interested in media bypass. Why we're not streaming media through the mediation server, right? So first of all, the transcoding. We do not want to have unnecessary transcoding between RT audio and G711 because it will affect the voice quality. Then, in most cases, you would like to have less boxes in branches. So it means you can install just a single mediation server in your central location for signaling only, and then having media locally between link client and existing, for example, router. Okay?
I think we've got a couple of diagrams that for on this, right, which picturize so you can really visualize where the media flows are and what it actually means as it goes through.
So then you can use your subnet configuration to define networks, which will be then used for determining media bypass ID. You will assign networks to the sites or regions, which is parts of call admission control configuration, and we will touch that configuration in details during the next session in the same room. Now, in topology builder, we need to define every gateway, even if it's not a signaling gateway, so it's not a call control gateway, it's just an MTP point, media termination point. Because only using this information, mediation server can then find the media bypass ID. So it should be defined like a virtual voice gateway, even if it's not configured for any voice route. Then you assign gateways to one of the mediation server. Okay, back to this is you need to configure on link side. In this example, for a call manager, you will need to configure MTP resources, which is mandatory for SIP trunk to link, is required by Cisco. Then you will need to create trunk, create route pattern, and associate it to trunk. Optionally, you probably will create a partition and calling search space for some quality of service to control the who can access that trunk. There is a configuration, just an example of configuration on the call manager side. It's for your reference. You can check it offline after that session. So, but as you can see, the most important thing here is to tick that box, media termination point required. So this is a route pattern which is associated to the SIP trunk, to link, to enable call routing. Yes? It depends. So the question is, can I summarize all the networks if I have like thousands of networks? So yes, you can summarize them based on the sites. So for example, you have site, logical site, all the gateways located on that site. You can say the network is a LAN network. There is no WAN links between these gateways and user locations. Yes, you can summarize them.
No, effectively to
I think he's talking about the subnet.
Yeah, subnets.
For column mission control purposes, you wouldn't want to summarize. You want it next so you can control.
If you don't put each one individually, right, you can have no CAC policy enforced globally, and it just defeats the object or purpose of deploying caller mission control in the network.
You can script all that too.
Yeah, exactly. So, but in case of using a proper call admission control, you probably actually split that networks to as much detail as possible. But yes, you can script it. You can use some external source as a feed for the script, and then just configure them in a bulk. Where we are. Yeah, the difference between centralized and multiple sites. I already touched it slightly. So in a centralized signaling, and media may actually go through the same IPPBX IP address. So it might be completely centralized. Or there might be a centralized call control, and then there might be a number of media termination points located as close to the link endpoints as possible. For multi-site locations, so in centralized design, you will probably define one IP address for your call signaling, and will use that IP address in call routing. and then we'll define a number of virtual voice gateways, which will be used as a MTP resources only. So they will not appear in your call routing configuration. But for multiple sites, you can also configure additional routings locally for the case when the WAN link is go down. But again, it depends on the capabilities of the local IP gateway. For example, you've got Cisco everywhere, and you're using MGCP to control your gateways. So you probably will not be able to add a SIP on that local gateway to talk to link directly. So again, it very depends on your existing configuration. Let's see some scenarios. So this is a media bypass occur locally. As you can see, there is a link front end, and link mediation server sits in your central location, and centralized call manager also sits only in your central location, but there is a ISR router with hardware MTP locally in a branch. Now, the signal will go through the WAN link. It's fine. It's not a huge amount of bandwidth. But media definitely will remain locally and will talk directly to Cisco MTP resource and then to the Cisco phone. In case of WAN link failure, media should remain, so the calls stay up.
That's after it's established.
Yeah, after it's established, yes. And we will touch on a scenario when it can be established after the WAN link has failed, but it will require SBA or SPS locally. Yeah. But in case if you're calling from link endpoint from remote branch to a Cisco phone located in your central location, you don't want to use G711. Based on the media bypass ID, link will determine, okay, we need to use a mediation server to transcode that call. And now, link will use RT audio narrowband on your WAN link to save some bandwidth, and then use G711 on a LAN network. The same will occur if you're making a call using a centralized gateway. So, for example, you are calling to another region, and you would like to use a least cost routing feature. So, disabling media bypass for this particular scenario might be very useful. Now, the WAN link should be failed on that picture. So with SBS or SBA located locally, the signaling can be established locally as well. So this is what you asked previously. So now to migration approach. Actually, media bypass can give you a lot of benefits when you're doing a migration. First of all, you can reuse your existing ISRs. And this is in case of Cisco, but it also applied for other vendors as well. So they should be just on the Interoperability program website, and you can use the same method. So that gateways now can be used by both existing IPPBX and link to make a PSTN calls. They also might be used as an MTP resource to calling from link client to existing IPPBX headset or handset. Then there is no additional licenses to enable direct SIP with most of IPPBXs or IP voice gateways. And then when you set up that configuration, you can easily start migrating users stepwise. So you can move users in groups from existing PBX to a link, and they will be able to call each other. This is a reference slide. Again, you can just look at offline. It describes how the signaling and media flow for different scenarios and where the media bypass occurs. However, there is an alternative migration approach, which Brendan and Selwyn touched during their session. So you can have a gateway upstream. In this case, your existing IPPBX not required, not mandatory to support SIP. It can be configured to use any legacy protocol. It might be IP or it might be a pre-ISDN connection. The gateway itself can do Active Directory lookup to check if the user has been already migrated to link. And also, that gateway can use Active Directory information to fork a call, or even to play some sort of backup scenarios. For example, the client is not accessible on a link client. The voice gateway can route it back to existing IP handset, with the IPPBX handset. And it's definitely help you to minimize IPPBX configuration, which might be very useful for migration. So, takeaways. First of all, we have a very deep video integration through the Open Interoperability program, and more vendors join that program every day and in the nearest future. The integration with IPPBX can help you to leverage your existing investments, can help you to do a very quick and very cost-effective proof of concepts, as well as it can actually allow you to use your existing equipment for a long time without any additional investments into the existing equipment. And native integration with media bypass can help you to minimize a number of amount of equipment in the branches, but still keep media locally to save your WAN bandwidth, and also provide better voice quality. So this is all.
Prize time.
Yeah,
Sorry.
prize time.
Yeah.
Sorry.
And we define what the prize is, though. Whether it's
Oh, no, this is, I actually want this one answered. If you have a read-only domain controller on site, do you still need an SBS for the gateway should the WAN link go down? This is for branch office.
Okay, the question is, if you have a read-only domain controller on the site, on the remote site, do you need to have a SBS or SBA? Yeah, for voice call control resiliency. Yes, you need, because domain controller, read-only or not read-only, actually doesn't play any role within a link environment. So, and you cannot coexist domain controller with any link roles. So you will definitely need to have, for example, SBS, which might be a virtual server running on some box locally. Yeah. Yeah.
Oh, wonderful prizes. All right. So the question is, will we have, going forward, continuous presence from the Link AV MCU? So the politically correct answer is we're always looking to develop Link. In terms of that, I can give you the standard marketing answer and just throw you a headset. But you know, obviously we're looking at lots and lots of things as we move forward. Oh, sorry. Yeah.
Does the Link client support presentations from, say, Tambo or life-size VC gear? Can you integrate?
No, so you wouldn't get that in terms of the meeting content from there. Piece push through. You're really just primarily pushing the audio media streams, right? In terms of not the content.
In some cases, the video endpoints, they can actually convert the sharing content into video.
Yeah, if you put it in a video stream.
In this case,
yeah, not as content itself, yeah. Sorry, yeah, on the back of there.
With your gateway
failover of SIP trunks on the gateway, you mean?
Yes, if you have an audio code or a ARRI gateway and you have multiple SIP trunks in there, and you have, say, one SIP trunk that needs to falls over, you fail out.
Yeah, because I mean, that's probably a gateway function, right, in terms of that PSTN failover? Actually terminating on the gateway, you mean, itself?
Yeah, so actually, the PSTN connection, you've got SIP trunks in there, having tested multiple.
In multiple routes
Yeah.
out, because you've just got
Yeah.
additional routes on the...
Yeah, first of all, you can, can we have a failover mechanism for a number of SIP trunks? Yes, you can. You can define it by additional call routing to alternative IP address, or you can have defined that IP gateways as a number of IP gateways and then assigned to a mediation server.
Come grab a... That's right.
Yeah, that's it.
So what, it's just an application today?
Repeat the question.
Okay. The question is how you scale out in terms of multiple offices to bring video to, to all of those things. Okay, and they want to see multi-party, right, in terms of that continuous presence. So once we go continuous presence, then we need to bring in a hardware-based solution to act as that, such as Mike waving his hand frantically from Polycom down in the front there, so talk about it in the bridge. But
So yeah, so if you wanted to do that, to integrate Link as well, you can do the RMX bridge, which we've been showing instead, which was part of that call.
I think that one earlier, I guess my question was, do we need to head down that path, or can we do it natively using the PCs and the webcams that we've already got, rather than using the Polycom solution?
you won't get the multi-party view. Yeah. You will only get switching video, right? So whoever speaks becomes active, their video and audio comes live.
So there isn't anything between.
Not natively in Link itself, no. They're good, these soft things, 'cause you can throw them.
So based on that, how many multi-party endpoints can you have in a conference?
So with software MCU on Link, it can be 250.
250 tested, right?
Tested, but basically you can have more, and then it depends on, if you're using a hardware MCU, it will definitely depend on capabilities of that hardware MCU. Yes?
Can you deal with multiple Cisco call managers? For example, we've got different offices, different extension numbers. Would it know how to route different calls depending on which? I mean, obviously we all go through one link server.
Yeah.
But would it know which
How do you route out to
Cisco
the different
call
ones?
manager to send the call to?
Yeah. So the question is, if we have multiple Cisco call managers or any multiple IP PBXs somewhere, can we configure a link to a multiple IP PBXs? Yes, we can. So the call routing or dial plan options are very advanced and sophisticated within the link. So yes, you can define a proper routes to a number of call managers, for example, and then based on the end user location, they can actually use the closest MTP resources, for example, to hit the Cisco environment. Yes. Now, external client, the question is, in terms of media bypass, how the external client and internal client behave. So for external client, it goes through the H server all the time. So media bypass may occur between H server and the gateway or mediation server locally. But yeah, for the external client, he always talks to H server. No.
Question was, do you need any additional config on Edge to do that? So, no.
Yes.
So there's no way to use the media bypass to
I'm afraid no. Keep an eye on Interoperability program because SIP trunk providers are also listed there, and all the capabilities they can provide also listed there. So you might find someone in the near future will provide that functionality, but not today.
Yeah, typically the recommendation, right, is termination on a mediation server in terms of on-premise, in terms of that SIP trunk. And when you do the SIP trunk, take the mediation server and actually don't run it as a service and run it as a physical server to keep that and isolate it separately away as well. So, but technically, yeah.
On that note, mediation bypass, does it go both ways? So say you have an outbound call, I jump straight to from my client straight to the gateway. For an inbound call, it goes from the gateway straight to the client as well?
Yes. So yeah, it works both ways. But again, check the Interoperability program. Some IPPBXs do not support one on another. So in some cases, it works for outbound calls only.
You get him on whether you like it or not. We're out of headsets on there. Okay, so we're pretty much out of time around there. If there are any additional questions, I mean, myself and Victor will be hanging around anyway, so we'll let the other guys set up for the next session on there. But by all means, come up and ask some stuff if you need to. So, thanks very much.
Yeah.
Well done.